people call your business every day. Sure, they can read your website and social media posts and could contact you via email or tweet. But when customers really need the personal touch, they call. As a business owner, you want to leverage the information that these calls provide to improve your call center operations, including voicemail communications and customer experiences, and to comply with all regulations. The first step to leveraging this information is to record and transcribe your calls. But instead of having to key in an entire call to create a transcription, a recurrent neural network automatically does all the work for you. Imagine you had a recording of someone saying, "tomato." We want to break apart that complex sound into 3 simpler sounds, each of which represents one of the syllables of tomato. This also breaks the original long, complex sound wave into 3 shorter and simpler waves. Now that the audio is in a format that's easy to process, we need to decipher what the call was actually about. This is done through the use of a recurrent neural network, which has a memory that influences future predictions. Each sound in order in an utterance should affect the likelihood and interpretation of the next sound an RNN will process. For example, if a caller said "tome," it's very likely that he or she will say "toe" next to finish the word. Having that memory of previous predictions helps the RNN make more accurate predictions going forward. Because it's analyzing one sound at a time, the RNN will produce a pronunciation-based transcription, which will now need to combine its likelihood scores based on a large database of specific domain vocabulary. In an RNN, the least likely transcriptions are removed, and the most realistic ones are kept. Recognizing speech is not easy. A neural network has to be trained by analyzing thousands of hours of audio documents within a target subject area, also known as a domain. Each node knows how to take in a set of inputs, apply weights to the inputs, and calculate an output value. By chaining together lots of these nodes representing simple inputs and outputs, we can model complete functions. In an RNN, the previous state of the neural network is one of the inputs to the next calculation. This means that previous calculations change the results of future calculations. After hundreds of thousands of iterations, the RNN can identify patterns in basic sentence structure. As the transcript becomes more accurate, punctuation is added to the end of sentence. Analytical natural language processing techniques are used to assess and improve the structure and flow of the output of Voci software, enabling accurate and meaningful transcriptions. Voci solutions use artificial intelligence and deep learning to enable you to understand the needs of your customer. With Voci AI, you bring cutting-edge acumen to your business. Contact us to learn more.